My name is John Matthews. I'm with Ingradata GmbH, which is a German company working with process plant design. So we're very specialized in piping applications. We have both 2D and 3D applications. They're desktop applications for designing process plants. This is our 3D flagship product, and basically is used for create a 3D model of a process plant before it's actually constructed. The data is stored actually in a Oracle database, and the graphics are then generated on the fly using our own graphic engine. So this software has been around for a number of years already. But one thing we've always struggled with in the past is how do we get this data into a DWG format? In the past, we've had to go through a lot of hoops to try to get things working there. But now with the new ODA Modeler functionality, we're able to handle these things a lot easier. 3D piping is actually, the components used in 3D piping, for design anyway, are quite simple. You have a number of very simple 3D objects. So a wedge, a cylinder for pipe, cones for flanges and that kind of thing, a torus shape for doing the elbows, boxes, of course, for foundations and things like that. So what we do when we want to export our format into DWG is what we would do is then handle the basic different kinds of components and use the ODA features. So, for example, a box. There's a function called create box in the drawing in the modeler, and of course that's very easy. That's just X, Y, and Z dimensions. Sphere is similar. Cylinder and cone, you can use something called create frustum. Now, what's new in the new ODA Modeler is that now there's also a revolve function, so you can make a surface of revolution, and there's also an extrude function for extruding. So let's just look at a couple of these things. I thought I would just show you a little bit of the programming, from a programming standpoint, how easy it is to use this stuff. So in VectorPipe, our piping program, we actually have small programs that a user can program themselves, but this one is actually a pipe, and pipe basically has a length and a diameter in order to describe it on the screen. Using the ODA Modeler, we just say draw a cylinder, and basically we create a solid, and then there's a function, as I mentioned before, create frustum, which basically creates your box. Yeah, it creates your cylinder. It's very simple. Let's look at another one that's more complex, but this is new. Now we can do a surface of revolution to make an elbow, and so all we do is see the red. We make a red circle there, and then revolve it through a certain angle to create a 3D elbow. And at the top there, you see we're just creating a circle with a certain radius, and then we basically turn that into a region, and then at the bottom we just call this revolve function in the ODA library, and there you go. You get the 3D graphic. Here's a similar function. If we have the top to a large tank, what we do is we make an arc that describes the top of the tank, and then revolve it around the center of the tank top. And once again, we just call a very simple function revolve. And the last one here, this would be like a pad for a support or something. And here what we can do is we can extrude the region, and you can also apply an angle to the extrude, so it can get not just a box, but we can get an angled sort of a wedge there in order to do that. So this is creating for a wedge here. I did have one issue with it, which may be fixed by now, but it only seemed to take a zero angle to go up, which means it couldn't actually create a different shape there. Okay, and this is the result that we get then. This is actually a SAT file generated from the DWG. So we generate both the DWG and then also an SAT file. Now, before we had this new library here, we'd have to go through either spatial, actually buy a separate library from spatial, or we'd have to basically facetize the thing ourselves. So this is a big improvement, and I'm looking forward to being able to do some even more stuff. There's still a few pieces missing. One is, for example, sometimes in piping you have an elbow that's actually reducing, so it's bigger on one end and the exit is smaller. So we need to be able to revolve it along the path, but with the scale factor applied, so that the end of it is smaller. There's also, for example, an eccentric reducer, where we have the actual, it's like a cone, except that it's a little bit offset. And in order to do that, we have to also have an offset possibility with the extrusion. And another one would be an offset with a wedge. But anyway, I'm sure these are things that the development team can fairly easily get a handle on. We're very, very happy with what's come down already. So, thank you.